Hi, the next section, two-sample Wilcoxon test, or Wilcoxon rank sum test, or Mann-Whitney test. So this is the test for testing mu x is equal to mu y, but we don't have any assumption on distribution of x and y. So some assumptions. So we have two samples. So xi's are IID and yj's are IID. And also x and y are independent. And observations are ordinal. So we don't have to have numeric observations. For example, the x and y can be ranks, the rating from the scale of 1 to 10. And under null hypothesis, xi and yj's have the same distribution. But alternative, these have different distributions. So we don't have any other distributional assumptions, but idea is to compare the general size of x and y. So we still compare the sum measure of center. So mu x is equal to mu y is the null hypothesis, and mu x is not equal to mu y, or mu x is larger than mu y or smaller than mu y is the alternative hypothesis. So we don't have specific assumptions, but philosophically we have the mu x and mu y, the measure of center for x and y, and we are. Okay, so the idea of the Wilcoxon test, we use ranks of observations. So suppose we have two samples, x and y. X is 10, 20, 40, 80, and y is 30, 90, 200. So you can see if you take average and do two sample t-tests, probably y is larger than x, maybe significantly, because 200 is very large number. But you can see this, we have 10, 20, 40, 30, 40, so many small observations, but we only have very large observation, 200. So the idea is we use rank so that distribution does not matter. So think about the rank of these 7 observations. Then smallest one is 10, second smallest one is 20, third smallest one 30, fourth 40, fifth 80, and sixth 90, and seventh 200. And we take summation of this. So sum of rank is 12 and 16, 12 and 16. But to calculate the test statistic to use, we subtract the minimum possible sum of ranks. For example, the x have 4 observations. So at minimum, we have rank of 1, 2, 3, 4. So sum of 1, 2, 3, 4 is equal to 10. 1, 2, 3, 4. So we define 2 as test statistic called W. And for y, we have 3 observations. So at minimum, we have rank of 6, the sum of rank of 6. So we subtract 6, so 10 is test statistic. And the idea is if W is too small or too large, then we reject null hypothesis. Okay, so next, how to calculate p-values. So basically, the p-value is calculated based on W. So we have more extreme situation than our observed W. So that probability is p-value. And remember that the total sum of ranks is constant. If we have n is equal to 7, total ranks is equal to 1 plus 2 plus up to 7. So that is 28. And W is 2 was the test statistic in the last page, but actually the W ranges from 0 to something, but remember that for sum of x, we subtracted 10, and for sum of y, we subtracted, sum of rank of y, we subtracted 6. So total rank is already 16. So 20 and 16 is the difference of these two numbers is 12. So W is up to 12. So W, distribution of W is just a histogram of the 13 possible values from 0 to 12. Largest possible value of 11 is 1 and 10, 9, and so on. And actually, this distribution is symmetric under null hypothesis. So symmetric at 6, because the probability that W is equal to 12 are the same, because it's symmetric. If under null hypothesis, X and Y have the same distribution, so rank, the sum of ranks of X, those are just random summation of 4 ranks minus 10. So the probability that that achieves the minimum and the probability that achieves maximum are the same. Okay, so if you generate just 7 random numbers and just randomly pick up 4, then those are just 4 smallest observations, and those 4 largest observations, those probabilities are the same because it's random. So this is symmetric distribution. So to define p-value, we calculate the probability that we have more extreme event than W. So we have observed W is equal to 2. In such a case, the more extreme case than 2 is 0, 1, 2. And also we think about the other way around. So the 2 corresponds to 10 and the 1 corresponds to 11 area is equal to p-value. And if one-sided test, we only count the one side of this probability, so p-value becomes half. So this is two-sided case. One-sided case, that we use green one. And the rejection region, that we can use the same idea. So the W, distribution of W ranges from 0 to 12. So for example, if we have this kind of distribution, and suppose that the total area of here and here is equal to 0.5. If this area is 0.05, then rejection region is W is smaller than 1 or W is larger than 11. So this is rejection region for the 5% significance level. So this is how to define the rejection region. So in general, if we have significance level, then we divide this number by 2 and we find the area which corresponds to that probability. Then that area is rejection region. So we have to be conservative. So if this area, the sum of 2 area is only 0.04, but additional beans, the probability becomes 0.7, then we have to take smaller one. So the rejection region is still W is smaller than or equal to 1 or 11 or larger. And one-sided test, we can just think about the one-side probability. And here's an example in our language. So remember that we have 2 samples, DT, Detroit, and Dearborn, DB. So we think about just rank with combining all observations. So the smallest one is 494, maybe 490. So this is rank 1 and rank 2, rank 3, and rank 4, rank 5, rank 6 is here, and rank 7, 8, 9, 10, 11, 12, right? So we calculate these ranks and summation of 1 to 7. 1 to 7 is dt, and the subtract by this number. So this is basically smallest possible summation, that is 1 to 7. And the Dearborn smallest possible summation is 1 to 5, so 15. So we calculate this, and Detroit have the statistic of W. So this is W, and this for Dearborn, W asterisk is 29. And Wilcoxon rank sum test, it reports just 6. And the p-value is 0.0723. So this is two-sided test in default. So that means the W is less than 6, or, okay, so what's the range? We have 12 observations. So total rank is the 12 times 13 over 2. So this is 78. So, and the minimum rank is 1 to 7 and 1 to 5. So this is 15, and this is 4, so 28. So we have 43. So the difference is 35. So W ranges from 0 to 35. And the W is equal to 6. So we have some histogram like this. And also the other way around. So we think about 29 to 35. We have also 7 bins. Then, so this area is p-value. So this total area is p-value. And that is 0.073. So we do not reject null hypothesis. Yeah, so you can also do one-sided test. If alternative is less, then basically the p-value is only one side. So only smaller W reject null. And if alternative is the other way, Detroit has actually higher score than Dearborn significantly. That is very unlikely because on average, Detroit has lower scores. So if W is equal to 6, p-value is actually very large, 0.976. So we do not reject null hypothesis at all. Yeah, so this is how to implement the Wilcoxon rank sum test in R. And so we don't do exercise, but just explain how to calculate this threshold. So basically, if the test statistic, distribution of test statistics is calculated by simulation. So we generate just 12 random numbers. Actually 12 just ranks, just 12 ranks. And just the 1 to 12, and randomly separate this into 7 observations and the 5 observations randomly. Then we calculate W. For example, 7 observations, maybe 1, 6, and the 10, and the 11, 12, and the 5, and 3. Then we can calculate W. So W is the summation of this minus the 1 plus 2 plus up to 7. So you can see that this is 1, 6, so 17, and 38, so 38 minus 28. So this is 1 plus 7. So 10. So we can simulate W as 10. Then we repeat this many times. Then we can make distribution of W. Then we can get the 1 percentile or 5 percentile or 10 percentile of W by simulation.